Assalamualaikum and good afternoon. Okay, last week we are done with chapter 1, reinforced concrete beam design. So today or this week, week number 6, we're going to start with reinforced concrete column design, which is chapter 2. Okay, so I'm going to speed up a little bit because Perak dah pergi jauh and we are just masuk chapter 2. Okay. So column, a function of column is a structure is to act as vertical support to suspended members such as beam and roof and transmit the loads from these members down to the foundation. Meaning to say any loads that come from above, maksudnya daripada atas, daripada column, because we have roof and also beam. Okay, beam ni pula mungkin dia punya load datang daripada slab. Okay, slab transfer to beam. Okay, and then the beam will transfer to the column. Okay, and roof daripada roof trusses dia akan pergi pada beam and so on pergi pada column lah. Okay, column are primarily compression member, although they may also resist bending moment transmitted by beams. Okay, because of column ni dia actually berdiri tegak like this. So mostly the loading yang come from above is basically axial load ataupun load jenis lain lah. Axial load meaning axial tu maksudnya betul-betul dekat tengah, equally distributed, so betul-betul dekat tengah daripada column. Okay, also mungkin dia juga ada resist bending moment transmitted by beam because of beam perhaps will come from here. Saya nak melukis. Okay, so beam ni akan transmit. So basically ada moment daripada beam ni akan transmit pada the column. Okay, column may be classified as short or slender. Maksudnya column jenis pendek ataupun column yang jenis kurus dan tinggi. Braced or unbraced meaning dia ada support, extra support or not, and depending on various dimension and structural factors. So ada many types of column. Common column cross section are square, circular and rectangular section. You can refer to this figure. So we have square, round and rectangular. The greatest dimension should not exceed 4 times its smaller dimension. So for square column dengan round column like this or circular column, this one not apply lah. But basically this is for C here, which is the rectangular section. If let's say H here is less than or equal to 4B, meaning contohnya you have B equal to 200. Okay, contoh saja. And H is equal to 800. Okay, so when you multiply 200 with 4, because you kira 4B kan, so 4B 4 darab 200, you will get 800. So you tengok you punya H, you compare dengan value of H. So H here you contoh saja we put 800. So it means it is equal lah. Equal ni. Less or equal lah. So the equal meaning kita consider dia as column. Okay, tapi if let's say H is bigger than 4B. So contohnya kalau H ni perhaps you tukar jadi 900. Okay, so H is bigger than 4B sebab H adalah 900 and 4BU adalah 800. So 900 is bigger than 800. The member should be regarded as wall for design purpose. So walaupun dia adalah column, you nampak dia macam column, tapi bila you design, you're going to treat it as wall. Okay, we have here failure modes of column. So there are 3 mechanisms, which is compression failure of concrete or steel reinforcement, buckling and combination of buckling and compression failure. Okay, for the first one is compression failure. This one normally, okay, kalau you tengok dekat bawah ni, Compression failure 1 is most likely to occur with columns which are short and stocky. So here we have the example of stocky and short column. So why this happen? Normally because of perhaps you tak provide, contohnya ini adalah contoh lah. Contohnya apa? Contohnya material failure lah. Contohnya because of you tak provide size yang bersesuaian, and mungkin concrete punya strength also tak betul, steel strength also tak betul. Maksudnya you design dia not according to the load yang being transferred. Maksudnya ada salah dari segi design. So dia ada failure in concrete or steel reinforcement. Okay, ataupun mungkin juga kalau you tak provide what we call this, link, ataupun kita panggil juga dia as tie. Okay, maksudnya link ni kita panggil dia tie juga. Kita boleh juga panggil dia binder. Dia benda yang sama tie atau link, binder. Okay, you tak provide binder yang sebetulnya lah. Okay, so dia itu akan menyebabkan failure yang macam ni And buckling, okay, sama je basically why it happen, but this normally happen to long and slender column. Okay, because of column yang lebih tinggi ni, that's why when kita design, kita kena consider whether that column is slender ataupun short and stocky column. Bila kita tahu which type of the column, so that we know how we going to design the column So that's why kita kena tahu jenis yang mana, baru kita boleh design dia ikut jenis dia. Okay. And also last kali is a combination of buckling and compression failure. So it happen to not short lah, maksudnya stocky, but also long column This one sama je because of the failure dari segi design, dari segi steel reinforcement you, dari segi concrete yang you letak tu tak betul. Maksudnya dari segi design failure and also also dari segi tie ataupun link yang kita letak also tak cukup. So this is what happen Okay. Because we need to check on whether macam mana kita nak design, maksudnya kita nak design dia as short ataupun slender column. Jadi kita kena classifykan column ni yang mana satu, baru kita boleh start design. Because of daripada awal pun kita dah tahu because of the failure yang mechanism yang sebelum ni. Jadi kalau you tengok sini, failure modes ni, okay, because of dia ada slender types and also ada short types of column. Jadi kita nak tahu, we want to avoid this failure from happen. Jadi kita kena identify dulu which type of the column, right? So to identify it, there is a formula here. Okay, column is classified as short if LEX divided by H is less than 15 and LEY divided by B is less than 15 when braced. Okay, but when unbraced, LEX divided by H is less than 10 and LEY divided by B is less than 10. Okay, what is LEX? What is LEY? Okay, LEX and LEY is actually effective height. Okay, but depends pada dia punya axis. Normally kita akan cakap x-axis tu adalah major axis lah. Maksudnya axis yang paling penting kalau tengok dalam drawing sekalipun. Okay, you ada drawing, you akan perasan ini adalah paksi X dan ini adalah paksi Y. Okay, so normally the major is X. What is effective height? So effective height ni sebenarnya dia tak sama macam height. Okay, dia to get the effective height, you have a formula. Okay, macam mana kita nak kira effective height? Actually, it depends on the end support of column tu macam mana. Okay, maksudnya sambungan column tu macam mana. It depends on that. Okay, bila kalau katakan you dapat effective length, okay, effective length yang lebih rendah adalah lebih bagus. Maksudnya dia akan kurang buckle. Okay, but effective length yang lebih tinggi dia lebih senang untuk buckle. Okay, jadi bila nanti kita akan tengok on the effective length punya cerita. Okay, dalam tu nanti you akan nampak ada you kena darabkan dengan factor. Okay, so factor tu depends pada end support dia macam mana. Sama ada end support dia monolithic or not, that kind of thing. Jadi kita kena tengok on that. Okay, so itu adalah effective line. Just what you have to know is like effective line ni maksudnya macam dari segi design Ini bukan dari segi whatever you might see physically. Maksudnya bukan bila effective line dia rendah so column you terus akan bengkok begitu. Bukan. No. Effective line ni adalah length yang you darabkan factor because of you want to know what will happen to the column bila you put on load on it. Macam tu. So maksudnya length yang akan buckle. Length yang ter-effect untuk buckle. Tu maksud dia. Okay. Jadi that is effective length. Okay, for X, we have to divide it by H here. Okay. So LE nanti you akan kira lah. So you pun kira dari segi XX maksudnya kolom you akan panjang ke bawah Panjang ke bawah. Okay. So dari segi part CX berapa tinggi dia and dari segi part CY berapa tinggi dia. Okay. This is bukan panjang ni Ini H. Ni tetap B. Panjang yang ke bawah sana. Tengok pada arah kanan. Okay. Panjang ke bawah sana. Alright. I nak explain about yang tadi kita cakap brace dengan unbraced column. Okay. A column may be considered braced if the lateral load due to winds, for example, are resisted by shear wall or some other form of bracing rather than a column. Okay. Kalau you tengok dekat sini. Okay. Here, there is no shear wall. So, this one we might consider it as unbraced. Okay. Unbraced column. Okay. However, if you look at here, figure 3.87 ni, it is unbraced in X direction. Okay, maksudnya X direction ni, X ni tak unbraced. But in Y direction, it is braced. Okay, it also can be braced in both direction. Contohnya, you have shear wall in the middle like this. Normally, kalau you pasang shear wall ni, normally kalau ada lift, kan, elevator, normally it is shear wall Jadi, you pasang shear wall, jadi it also consider kolom-kolom yang lain-lain ni adalah brace. Okay, in both direction because of shear wall. Untuk lift mungkin dekat tengah-tengah ataupun you ada core dekat tengah-tengah tu for the sake of bracing. Okay. Kalau you tengok dalam gambar ni okay, unbraced frame, lateral load must resist and transmit down to the foundation by interaction between beam and column frame members. And this one adalah braced frame. Nampak ada dia panggil brace B kat sini. Okay, lateral load transmitted down to foundation through a system bracing or shear wall. So maksudnya lateral load yang transmit pada shear wall. Okay, column only transmit axial load. Dia tak terganggu dengan lateral load. Lateral load tu contohnya macam angin, anything yang macam horizontally. Okay, load horizontal, jadi dia akan shear wall yang akan transmit. Shear wall ataupun brace B itulah yang akan transmit pada foundation. Okay, bukan column. Okay, column hanya support axial load. Alright. Okay, this one baru I cerita pasal effective length okay, the formula we have LE divided by, okay, this is the one yang I told you. Okay, B and darab dengan LO. Okay, B ni adalah factor tadilah, function of fixity at the end of ends, at the column ends, tapi dia adalah factor maksudnya you kena darabkan dengan something nombor pada based on fixity at the end of the column. Okay, LE effective length, so depends lah arah Y atau arah X, and you have clear height between lateral distance, so maksudnya height of you punya column lah, nak sampai ke beam tu berapa height dia. Okay, alright. We look at here, and condition 1 signify that the column is fully restrained. The first one, kalau tengok fully restrained. Okay, the second one adalah partially restrained, and the third one adalah nominally restrained, maksudnya restrain yang paling kurang lah. Okay, jadi dia ada 3 jenis. Okay, but normally kita kat Malaysia, because of we are using a concrete design, maksudnya design yang very fixed, jadi kita akan normally akan pakai number the first one lah, column is fully restrained. Okay, but okay, kalau you nampak kat sini there is end condition at the top. Okay, 1, 2, 3. Ini end condition at bottom maksudnya macam mana dia connect dengan, maybe dia, sebab dia akan connect dengan column below lagi kan, kalau you ada buat bangunan bertingkat-tingkat, ataupun dia akan terus connect pada foundation. Okay, and for this one end condition at top, macam mana dia connect mungkin pada the higher the beam and ada column lagi ke atas, how dia akan connect on that okay, so end condition number 1. Okay, the end of the column is connected monolithically to beams on either side which are at least as deep as overall dimension of column in the plane considered. Okay, jadi dekat sini, okay, you have the column, okay, and then you have the beam here. Okay, so you akan tengok yang belah bawah, sebab sekarang kita tengah tengok end condition yang bawah okay. Okay, both side adalah on this type of end condition So where the column is connected to foundation, it should be designed to carry moment. Okay, so depth of beam is bigger than depth of column. Okay, so apa maksud dia? Beam you punya depth, you know, this one kan. Okay, we have B, so this is beam. Okay, and depth of column. So column you ada arah X and ada arah Y. Okay, so berapa ni? Okay, so kita akan tengoklah. Maksudnya kalau depth of beam ni lebih besar daripada depth of column, so depth of column tu you kena tengok you buat arah mana lah. Kalau you buat untuk LEX, you akan tengok arah X punya depth lah, which is B. Okay, which is B, you akan tengok B of column ni you akan comparekan dengan height of beam ni. Tu maksud dia. So kalau dia lebih besar daripada depth of column, dia adalah end condition, end condition 1. Okay, but okay, end condition number 2, if the end of column is connected monolithically. Monolithic ni, kat sini ada kata monolithic, I tak explain. Monolithic ni maksudnya dia menjadi satu, as in dia very rigid lah. So maksudnya beam, column, dia you concrete together, so dia monolithic ataupun slab, so you akan concrete together, so dia monolithic So the beam of column is connected, becoming one, to beams or slab on either side which are shallower than overall dimension of the column, in the plane considered. So depth of beam ataupun slab, okay, beam atau slab ni maksudnya kalau mungkin you boleh juga pakai reinforced concrete slab. So reinforced concrete slab kadang-kadang ada juga kita tak pakai beam, okay. So maksudnya slab tu sendiri yang duduk dekat atas column, tapi this one jarang lah sebenarnya, normally is beam lah, okay. So beam ataupun slab ni apa-apa yang connected dengan column ni lah, okay, dia less than depth of column. Kalau you tengok sini bigger, okay, yang end condition number 1, this one bigger, this one dia less lah, okay. Jadi dia adalah end condition number 2. And last kali we have end condition number 3. The end of the column is connected to member which, while not specifically designed to provide restraint to rotation of the column, will nevertheless provide some nominal restraint. Maksudnya dia not being designed monolithically. Maksudnya dia tidak menjadi satu. Dia boleh bergerak-gerak. Dia tidak di-concrete together. Jadi dia ada flexibility and such. Jadi dia adalah end condition number 3. Okay, jadi bila you refer on this one, so you will know which one yang dia punya lah. Okay, contohnya kalau you have both side fully restrained, which mean end condition number 1, you akan ambil this one But if you have like end condition at the bottom ni, maksudnya column dengan beam dekat bawah sambungan dia lain, and column dekat beam yang atas sambungan dia jenis lain-lain, you akan select yang berbeza-beza ikut this table. Okay, alright. For the syllabus that we're going to learn in regards to PGN 242, we only covered short brace column design. Okay, for brace column, kita takkan masuk on the slender column. Kita just belajar short brace column design, macam mana cara nak kira So for design purposes, BS 8110 ni ada 3 category of short brace column. The first category is short brace axially loaded column. Okay, we look at that. B2 will resist axial load as it supports beam equal in length and symmetrically arranged. So kalau you tengok dalam gambar rajah ni, B2 ni kita panggil dia as axially loaded column only because of dia punya loading adalah symmetry, maksudnya betul-betul dekat tengah-tengah lah. So it is only axial load sahaja. Okay, axially loaded column. For the second one is short brace column supporting and approximately symmetrically arrangements of beam. Okay, for this one you look at C2. Okay, column C2 dia support symmetrically arranged beam, tapi if you notice here, this beam lebih panjang compared to others. Okay, jadi dia resist axial load and also provide moment provided that the loading of the beam are uniformly distributed. Meaning beam ni dia punya load adalah uniformly distributed, jadi dia transfer tu memang uniform transfer. Okay, and the beam spans do not differ by more than 15% of the longer the moment will be small. Okay, and another one, last kali we have a short brace column supporting vertical loads and subjected to either uniaxial or biaxial. Okay. Last kali. Okay. So kalau condition A dengan B, maksudnya condition A yang macam ni, maksudnya dia symmetrically arranged. And also sama saja panjang-panjang beam dia. Okay, jadi dia adalah condition A. Okay, tapi kalau condition B macam C2 sini. Okay, ni B2 ni C2 untuk condition A and B. Okay, alright. But for condition yang last kali which is column resisting axial load and uniaxial or biaxial ni, okay, contohnya, okay, the moment here become significant and the column may be required to resist. So dia kena resist beberapa termasuk moment and axial load and uniaxial bending. Okay, kalau you tengok beam B1, C1, C1, okay, and then we have B1, B3, B1, C1, B3 and C3. Maybe I should use a different color instead of using this color so that you akan nampak lagi. Okay. Okay. Condition yang ni and axial load and uniaxial bending. For example, you have like B1, C1, and then you ada B3 and C3. Okay, you tengok sama je. Dia ada like 3 beam yang connected. And then you have A2. And then you have D2. Okay. This 1, 2, 3, 4, 5, 6. Okay, so this one termasuk dalam axial load. Okay. Yeah, and also uniaxial bending. Maksudnya uniaxial bending maksudnya banyak lah. Okay. Dia ada lebih dari satu axis Okay. Tapi dia tak sama macam yang the first one, sebab first one tu symmetry, ini tak symmetry. Okay. Jadi dia dalam this category. Okay. And also you have another one which is, tukar color lagi. Okay. An axial load and biaxial bending which is A1, A3, D1 and D3. So if you see this one, okay, dia ada axial load juga. Okay, tapi it is biaxial bending. Maksudnya ada 2 axis lain untuk bending. Okay, dia kena resist bending moment. Okay, so this is 3 categories. Okay, so we have like yang you kena ingat lah. Okay, so inilah dia. But in our syllabus, kita belajar yang the first one saja, which is short base axially loaded column. Untuk mengira but you have to know jenis-jenis design. Macam mana you nak design yang dia termasuk dalam 3 kategori lah. Sebab lain-lain kategori, lain-lain cara design dia. Okay, tapi kita just cover on axially loaded column. Okay, which is the first category, symmetry. Okay, this one axially loaded column, the one yang we covered. Okay, this is the formula. Okay, N equal to 0.4 FCU AC plus 0.75 FY ASC. Okay, I rasa you dah familiar lah dengan what is FCU, what is AC, FCU and FY Tapi AC dekat sini, tengok net area of column. Maksudnya dia adalah net area of column, maksudnya area of concrete. AC ni adalah net area of column ataupun area of concrete. Okay, and ASC here is area of longitudinal reinforcement. Maksudnya main bar lah. Kenapa kita panggil longitude? Because of column dia ke bawah like this. So bar will be like this, around like this lah. So you have a longitude yang memanjang ke bawah. Jadi it is a longitudinal reinforcement. Okay, and here is ultimate axial load, which is berapa loading yang boleh disupport lah kalau you ada concrete strength macam ni, steel strength macam ni, and size apa area of concrete macam ni, area of steel macam ni. Jadi axial load berapa yang dia boleh support. Okay, so that is the formula. Okay, in column tak banyak formula This is the one lah. Okay. Masih sama strength of reinforcement, high yield steel, mild steel 250 to 60 masih sama. We are going to refer to this one also. And concrete compressive strength masih sama. And we also going to use the same table which is cross section area of bar kalau kita nak cari area of steel. And also ada requirement for links. The diameter of link should not be less than 6 meter or 1/4 of the diameter of the largest longitudinal bar. Bermaksud dia, so diameter of link, okay, bar size ni you faham lah. So kalau kita kira spacing, kita kira link ataupun tie or whatever lah kita nak panggil dia. Okay, so bar size adalah 1/4, 1/4 of the diameter of the largest longitudinal bar. Okay, so 1/4, 1/4 daripada diameter apa? Diameter main bar lah ataupun longitudinal bar. Okay, and for spacing, okay, ini adalah untuk bar size ni, ini adalah minimum size minimum. Okay, minimum size lah. Tak patut tulis bar, nanti you confuse. Minimum ataupun minimum diameter pun sama je. Minimum maksudnya tak boleh lebih kurang daripada value ni. Okay, and also kalau you perasan kat sini, it says also 6 millimeter. Maksudnya kalau katakan diameter you contohnya 12 mm. Okay, diameter of longitudinal bar ni, longitudinal bar main bar 12 mm. So you kira 1/4 darab 12 mm. So you dapat 3 mm. Okay, tapi it state here that 6 mm ni adalah minimum. Okay, jadi you dapat macam ni, tapi you kena pakai 6 mm. Sebab size bar tak ada lagi rendah daripada 6 mm. Okay, kalau you tengok pun dalam this one, okay, you nampak bar size 6 mm paling rendah. Jadi 6 mm is the, you cannot go lower than, you cannot put 3 mm. There's no, ada kalau you buat customization, you order special order lah. Okay, but ada sebenarnya. Okay, tapi kita tak pakai, maksudnya dia memang dah keluar clause yang mengatakan 6 mm ni kita tak boleh guna untuk link low than that. So the minimum is 6 mm. Alright. And if kalau katakan that one kalau rendah, contohnya lagi satu, 1/4 times perhaps you punya ni 32 mm. So 1/4 darab 32 adalah berapa 8 mm. So 8 mm. Okey lah. So kita akan pakai 8 mm. Sebab 8 mm lagi besar pada 6 mm adalah the minimum size You dapat rendah, you ambil 6 mm. You dapat lebih, pakai value tu. Okay. And also another one, kat sini ada juga state about spacing. Okay. Maximum. Okay, ini minimum size, maximum spacing. Kan spacing the more tight, maksudnya tighter, the tighter the better. Maksudnya beam you spacing, link punya spacing tu lebih rapat, lebih bagus Jadi dia ada maksimum, maksudnya tak boleh melebihi, maksudnya spacing tak boleh lebih besar pada value tu. Sebab kalau lebih besar spacing dia terlampau jauh. So kurang bagus lah. Okay, the formula is 12 darab diameter. Diameter apa? Diameter of longitudinal bar. Okay, kenapa ada perkataan smallest, largest or whatsoever ni? Okay, because of sebenarnya kalau kita design, for column, kita boleh mix. Even for beam pun sebenarnya kita boleh mix bar. Kita boleh mix diameter bar tu. Okay, untuk to fulfill area we need, we actually can combine diameter of bar, different diameter of bar, kita boleh combine. Okay, but I tak ajar lah sebab nanti you makin pening. But you should know it can be combined. Okay, jadi kalau katakan you have mungkin combination, mungkin you pakai ini adalah 16, mungkin you perlukan sampai 8 Okay, you can put like 12mm kat sini, depends 12mm and 12mm semualah mesti samalah. So this one 16mm and 12mm dia combine, boleh. Okay, tak ada masalah. Jadi bila you combine bar macam ni, kalau spacing you akan pakai paling kecil punya, maksudnya pakai 12mm. Bila you kira dekat sini, maksudnya you kira the diameter ni, you akan dapat some value lah, which is what, 144. Okay, but kalau you kira for this one, for minimum size link ni, okay, you kena pakai largest longitudinal bar. Okay, maksudnya kat sini you darab 16mm lah contohnya. Okay, alright. So itu saja. I akan proceed dalam record another one yang I akan record untuk second part. Okay, thank you.